Hello everyone. For this tutorial video, I'd like to discuss irregular polygons, which are the most difficult to analyze out of shapes that are made up of only straight lines. As we may already be able to guess, an irregular polygon is a polygon whose sides are not all equal in length. Similar to how, in everyday contexts, irregular is the opposite of regular. However, what makes this tricky is that because an irregular polygon is literally any type of polygon that does not have equal length sides, it involves a huge, nearly infinite variation in the exact type of shape, owing to how broad this definition is. However, even though the objects will have to be analyzed on a case-by-case basis, it is not anything to get worried about, because we can vastly simplify the area and perimeter of any shape using the shapes we already have at our disposal. For example, a baseball home plate is an irregular pentagon, but can be simplified into a rectangle with an isosceles triangle, which we already know the area and perimeter of. So we say the area of the plate equals the area of the rectangle, which is the length of the plate times the height of the rectangle, plus the area of the triangle, which is 1/2 times the length of the plate times the height of the triangle. Similarly, we can see the perimeter is the length of the rectangle plus 2 times the height of the rectangle, although we notice the length does not have a factor of 2, because the second leg of the length of the rectangle is inside the shape and therefore is not part of the perimeter. By the same exact logic, the base of the isosceles triangle will not get factored in because it is on the inside of the shape as well. So the perimeter of the isosceles triangle is 2 times the square root of 1/2 times the length of the triangle squared plus the height of the triangle squared. So we add that to the perimeter of the rectangle and conclude that it is the perimeter of the entire shape. Although the baseball plate is an irregular polygon, it is still a relatively straightforward one to analyze, and many irregular polygons will not be as pleasant to the eye, but will instead look like an abstract mess. But if we are creative in our problem solving, we can still simplify them into simpler to analyze shapes. For example, this shape that resembles something you might find on a map can look very confusing or overwhelming at first, but can actually be seen as a kite, another kite below it, a third kite to the right of that, a fourth kite to the bottom left of that, a fifth kite to the right of that, and then finally an isosceles triangle. And so we simply treat the overall object as the sum of the areas of all of these individual shapes, which we know the formulas to already. And the perimeter calculation follows the same routine, namely that you calculate the perimeter of all the individual shapes, and then subtract all lines of the shape that are inside the shape rather than outside. Note that for complicated objects like this, there is no one right way to break it down, but rather depends on what shape you are most comfortable using. So for example, the topmost section could have been a scalene triangle with a kite beneath it, instead of being one kite, like so. However, the conventional technique is to break it down in the easiest way possible, i.e. that you do not use more shapes than absolutely necessary. Although, we have seen how we can analyze any type of polygon possible by breaking it down into simpler polygons, we still have not learned how to analyze every type of shape possible, because polygons are shapes that only have straight lines, which is not true for many shapes. So we will transition our studies to the analysis of curved objects, starting with the most simplest, the circle, in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos and follow me on either Facebook or Twitter for more content.